Hi guys! Hi, I am Nickey.
Hi, I am Jackey.
Together we discuss future of design.
So now let's delve into a topic which will seem a little technical to people, but I think it is very important for a design engineer to know this because at the end, the design engineer will be designing the experiences and will be playing with the system design. Let's talk about embeddings, vector DB, vectors.
Right. I think you rightly mentioned about these three topics because these are so essential for a design engineer to know. They will not be creating embeddings, they will be not defining vectors, maybe not even playing with vector DB, but it's so important. It defines how the experience would be, and knowing these concepts will definitely help them in better defining the product strategy. So let's go ahead with what's an embedding. So embedding for a designer, just like a mood board coordinate. So imagine we have a giant mood board map. What happens in a mood board? We place similar objects close to each other because it says about certain trends or themes, and we have different sort of images in close proximity. We can take the same analogy with embedding. So for example, we have a map, and every word, every sentence, every image becomes one dot in the map. The dots with similar vibes are in close proximity with each other. For example, this dot is gold, and let's say here we have one more dot which is silver, and we will see that gold and silver will be in close proximity. But if you have a wood, so it might be this, right? And you can literally see that the distance between gold and wood is far than gold and silver. So if we talk something around gold, the AI can understand that the nearest information that closely matches with gold is silver.
Yeah.
So there is something called fish. Maybe there's this dot in the map, and you can see it's like way more far than the gold. So ideally what AI knows is there is pretty less relationship, or there is a weak relationship between fish and gold. Now this, if you see, it's a 2D. A 3D map is like in 3 axis, but embedding can have like tons of dimensions, which is basically an extended coordinates of that particular word or sentence or anything. In a nutshell, an embedding are these dot coordinates, and these dots, as we talk, it could be words, sentence, images, anything.
All right.
So the next important topic that we should know is what's a vector. Vector is just a list of numbers. This is 2D, which is x and y. So if there's a point here, this coordinate, let's say this is x1 and this is y1, right? The coordinate of this one will be x1, y1. So if I have to tell this point B where it is exactly in this space, you can just say, just go x1 and y1, you will get point P. In 3D, what happens? You have one more dimension, which means you have a z-axis. Now this dot might be somewhere around here, so which means it'll have a z1 axis also with it. Now if you give these three coordinates, this coordinate which has 3 axes, you can easily find out where exactly your key is in a 3-dimensional space. An embedding can have more dimensions, which means an embedding might look like let's say we have a word called arrow, and it might have embeddings like 0.12 minus 0.44, 0.07, and it can go up to like maybe 128, maybe 100, which means this vector has this huge coordinates which you can find it in that vector space. This is what we call as a vector.
So why are we not storing the vector in 3-dimensional space? Why are we storing it in multiple dimensional space?
That's a good question. What is vector? It describes the meaning of this particular word or anything. Now this meaning is so complex. You can't store in just 1 or 2 dimension. The more dimension you have for a word, you can better relate to other words. If you want to know about a person, you know in so many different ways. The better you know the different nuances of the person, the better you understand and differentiate with other people. But when you just meet a stranger, you just know a few things about it. Maybe just what's his gender, where he's from. But if I bring one more stranger in front of you, you can't differentiate between both of them because you just have a small bit of information. So the more number of meaning is stored in a vector, or the more dimension that's stored in the vector, the more better when you represent this each vector. In vector space, you will be having maybe 100 dimensions. We are just talking about 3 dimension, and it's easy for me to draw it out and show you that how dimension works, because there are like hundreds of dimensions. and it's very easy to put that word as one dot in that map. And let's say there is a word called arrows, and if that vector looks something similar to here, maybe slight difference, instead of 0.07 it could be 0.79 and so on, you will see in that space this word and this word will be in close proximity. So when you ask or try to find out what is the closest information related to this particular context, it will suggest that, hey, these 10 things are in close proximity. It will never suggest fish because it's way far.
So this means that if we have more vectors, then the model understands better relationships.
Yeah, more dimensions, you basically store meaning in better way, more efficient way. Now it's easy to find out other words that has closer meaning to that.
Hence, the model can draw better relationships.
Right, because you're capturing even the tiniest nuances of that particular word as a meaning, and this meaning is stored as number. What they're actually trying to do is they find out the similarity between different words. So if it's in the same direction, which means it has same meaning. If two vectors are in opposite direction, which means it has different meaning. Now this word beautiful will have an embedding vector. An example like 0.12 minus 0. Let's say 44 and so on. So these embeddings are vectors, and these numbers are learned during training. So we're talking about VectorDB. A close analogy of VectorDB is Google Photos, but instead of photos, it's for meaning. So what we do right now, so we ask with keywords before when we do Google search or anywhere when we want to do some search, we type some keywords and it goes and finds similar information around the keywords. Here in a VectorDB, it stores embedding vectors. We just talked about embedding vector, and this is an embedding vector, and there will be like millions and billions of that. It also stores the regional items, for example, document chunk, UI components, ticket image, and then some metadata, like for example, date. So if you say, give me top 10 closest dots to my query dot. What is meant by query dot in here? So you just say that give me the top 10 closest words to gold. So immediately goes in the VectorDB. It might see like the gold has closest to silver, maybe copper, maybe aluminum. So it will start fetching out from here because it knows that this is the closest thing to me, and it will never bring like wood or anything because it's so far away from that.
Yeah. So why this exactly matters to a design engineer?
Right. So if you're building AI features inside products, embeddings becomes our best friend for anything involving finding the right context. Let's say an example. So we're designing some natural language search for design systems. When the user asks like button with subtle outline and high contrast over, what we'll do is embeddings will help match what are the right components, component docs, maybe tokens, usage rule, because this all things might be stored as vector embeddings, right? What will happen is the moment user gives a query, it will convert that into a vector, and then it will go in the VectorDB, right, and see that. So let's say this vector v1, which are the closest vectors related to vector d1 in the vector space. Now this is not three-dimensional, it's multi-dimensional. Just give you an example, and it sees that, oh, this number has this proximities, and it will use that information for query responses, right? So other example, if you're designing some clustering and summarization for UX feedback, right? So there could be thousands of comments like slow, laggy, takes forever. Now what we'll do is these embeddings will group them by meaning. So in vector space, it might put like slow, laggy, takes forever, this kind of thing in close proximity. So when users ask anything or user says anything about a negative sentiment comment, it knows that what it has to do post that. There are multiple examples. If you want to do similar screens for internal tooling, what you can do is you can create an embeddings for screen descriptions. You can define for component trees. You can create embedding for UI screenshots, right? This will be called image embeddings. And then if you ask a query to an AI like show me flows similar to error handling, so what it will do is it'll convert this whole query into vector, and it will find out which are the closest screens, because you're asking flows. So it might go and find out which are the closest flows or vectors that is closest to this particular vectors, and then it will find out the right flows that matches to your error handling checkout page.
Oh, so this means that it is very important for anyone to store a very specific information in the vector database, because if we store a generic information, then it will actually have no use of creating a vector database.
Right. If you generally ask any query to an LLM, it will refer to its knowledge and respond to you. But LLMs are trained on billions of data, so it will be a generic answer. Now, in business, what we usually want is to give information that's based on source of truth, and a source of truth is databases. Usually a company have databases like SQL, relational database, or maybe non-relational database like MongoDB and all, and those are the exact data which comes from the users, transactional data, anything. If you're asking like, hey, how much did I spend in the last 1 year? Now, if you ask this question to an LLM, it'll just go and give you a hallucinated answer because it doesn't know where it has to search. So either you do a tool calling, connect it to your DB, which will go and query out the right responses, but there will be a latency costing. Else, what you can do is you can take that 1 year worth of data, save it in a vector database, which means in normal database like relational database and non-relational database, you don't store meaning, although the data is there. But in vector database, it stores the meaning of these words and how they are related to each other. So that the moment you ask like how much I spent last year, query itself, it gets converted into a vector, and this vector is being searched in the vector database as like which other vector databases are close to this vector, and then it responds with the information. Now the LLM will parse this information and structure it, which means that whatever information you're getting it is based on your own data, not a general data.
So now whenever we are creating any agent and we're utilizing any sort of LLM, so it becomes very important for us to create vector database.
Yes, that's what we have been hearing the word RAG, retrieval augmented generation, which is nothing but uses vector DB. Now it always grounds your information on sources. That's what Perplexity is really good at. The reason we are talking about vector database is not to go and create a vector database, but to know that if your product has to give rights information grounded to your data. So there are multiple ways. So vector DB is a really good way to speed the response time. Plus, instead of LLM being so generic, it can always give you information grounded on your own set of data. So you want to create a repository of different products we have in our company, and then we create an RAG database with all the UI screenshot with all the design system. Now what will happen is you don't always have to go and open your Figma and find out which component is making sense. You can just say that, hey, I want to create a dashboard to monitor my health, and this is my need, and it can suggest you that there are these things created before, and it can give you responses around that. For health, this kind of KPIs make more sense, and run that.
All right.
If you're designing serious product grade AI like design of UX tool, so the embeddings are one of the core ideas behind how we deploy RAG, what is semantic search based on meaning, not keywords. How you're doing tool plus doc retrieval personalization, like how we are showing similar to things you like, and smart defaults. So it's like based on your past context, we are defaulting certain preferences for you. Because as a design engineer, you'll constantly face this question, how do we fetch the right context before generating? And the answer is simple, embeddings.
A model will eventually have embeddings in general.
Yeah, see, that's a model embedding, which is right after tokenization. So embeddings are also a part of LLM training. After tokenization, embeddings, again, these tokens with meaning are stored, but it's done on billions of data. Why embeddings are important for business use case? Because you create those specific set of information that's related to your business, and you create smaller embeddings, which is grounded on your data. And instead of it tapping on the LLM tapping on its knowledge, it taps on your database knowledge. So it gives you right information, and that's how you reduce hallucinations if you go with the vector database.